Welcome back. Um, so in this video, let's talk about the ground rigid bodies. Very exciting. So just an overview for what we'll talk about for the rigid bodies is that remember that this explosion thingy happens on the first state of our deformation on the ground. So what we need to think about is that we have to take that state and then fracture that. And then for the second state of the deformation, we'll be using that as a collider for all these rigid body pieces. All right, so without further ado, let's hop on to Houdini. So the ground rigids are in this node, the brown one, and in this node I'm just fetching the ground from upstream, which is this guy, this ground. And remember, we've got UVs on this ground, so we gotta maintain those UVs throughout the whole process of the rigid bodies. All right, so the first thing I need to do is, obviously this is a deforming time dependent node. I'm gonna need to time shift the ground to where that first state of deformation is. So technically this is where we want to fracture that. And the next one is the second state of the deformation, where we will be using as a collider for the rigid body pieces. And also as a mask, because remember that thing that we've got, the mask crater and mask scorch. We just visualize that. Right, from attribute, we got the mask crater. We just put the infrared, and we've got mask scorch. So yeah, we got these masks, right? We'll be using these for some pretty fancy masks on the deformation on the ground. All right, so all I'm doing here is just copying those masks. So I got the mask crater, mask scorch on this stream. I'm just renaming them to mask crater 2 and mask scorch to mask scorch 2 because I don't want to interfere with the current masks that I have on this state. So I'm just attribute copying them. I can use an attribute copy because they're literally just the same topology, the same point count, the same point order. So I'm just grabbing those mask crater 2 and mask scorch 2 from the second input. And the next thing I want to do is isolate the simulation area. Awesome. All right. So the next thing is I want to show you guys how I've done the fracturing first. So as you can see with this color class node, I'm not generating new points or anything. As you can see, sorry. What I meant to say is I'm not cutting them based on some Voronoi fracture because I kind of just want to maintain the topology, if you say so. And how I did that is, since I've got all these resolution on the ground, I could just use these. It's essentially like an edge fracture where, oops, not convert line, edge fracture, geometry to fracture, and let's have a look. If we just remesh this thing and we drop down color swap, connectivity, copy that, primitive and random from attribute. Oops. So if you just have a look at this, So what the edge fracture is doing is just tracing along. It's like a Bronner fracture, but it just traces along the current edges that we have to create these pretty organic looking organic fracture without having to do some. So if you do a Bronner fracture with scatter points, I'm just gonna use this guy. Down, 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 or let's say consistent, and let's do the remesh. So, whoops. And we do a void manufacture without any interior pieces. So you can see how straight our cuts are. That's because it creates new points along these edges. So before and after, it's creating new edges. So I kind of didn't want that. Or there are ways to go around this by using some. So we would mountain it up first before we fracture. Start a rest. Oops. Rest. Down here. And do some mountain thingy. Whatever. And then we scatter points and do that. And then with another rest node, we say extract rest. We just compute our normals again just to get rid of that faceting. Now if we see our Voronoi fracture, now we have these nice looking organic lines. So it's kind of hard to fiddle around with the look of it. And you can get artifacts like these things coming in and non-convex shapes. So that could be an issue with the rigid bodies. So the easiest way I found is that we would do some kind of edge fracture way, where we've got these edges, but it's just using the existing edges that we have on the topology and cuts it based on that. So the way I did that is simple. What we want to do is split these points based on some interesting data. So we obviously know there's this thing called vertex split, and we'll use this node to split the points based on an attribute. So first thing we want to do to cluster it up, I will just scatter points, maybe just 35 points, and then store an attribute in here. Let's say index at ppnum. So I'm just storing the point number of these points into an attribute called index. Awesome. Now all I'm gonna do is just transfer this attribute onto my points. And we've got that. And if you do color swap random from attribute, you've got that nice looking clusters thing. Perfect. But on the point split, the attribute it needs is either a vertex or a primitive attribute. So all I'm going to do after I transfer that index attribute, I'm just going to have to promote that from points to primitive to index. So if you just leave everything at default and do the vertex split, index, I'm going to do a color and connectivity. You can see some weird stuff going on here. So instead of doing an index, an average promotion method for our attribute. Let's just set it to maximum. And now we get rid of that issue. Perfect. Cool. So now, if we put down an exploded view, these things would be separate pieces, and we've got all of these nice cracked up edges and everything like that. So that looks pretty cool, and it would be easy to just create a 4HP, I don't know, convex decomposition. And we go here. Let's create a name first. Create name. And composition. And here we go. This is our convex hull. Basically the collision representation in the rigid body solver that we'll be using for these nice detail pieces. So back to our ground. We isolate the simulation area, and in here on this stream, all I'm doing is grabbing some masks, creating some masks, so all I'm doing is find the difference, like how far have I come off of my position from the first state of deformation to the second state of deformation. So in here, I'm just calculating the distance between my current position and the position on the second input, and fitting that into a ramp and coloring the ground based on that mask. So now this is my mask. I'm putting that into a color attribute and a mask underscore active attribute, which I'll be using for some simulation properties stuff. So I'm just scattering based on that color attribute and based on the CD. So now all I have is some points on those masks. So we have more points towards the center, as that's where the color is the highest, and as it fades off, we've got less points. Cool. And now I'm just storing the point number on this scatter thing into an index attribute, transferring the index and mask active attribute, promoting the index attribute to the primitives, so then we can do the vertex split. So now if you see, this is our fracture. Very, very cool. Got a lot of details here. Okay, so now because this is just a plane with no thickness, I'm just gonna have to extrude this, and remember to output back, and for the side we're gonna have to say it's the inside of the pieces. I'm just reversing the normal so I don't get the issue with the back face facing outside. Reversing that and then recomputing the normals. Cool. And then I'm just creating the name for these pieces, and all right.